I will configure BGP. So when I will configure BGP on all routers, between router 1 and router 2, we will have eBGP neighborship. We will have eBGP neighborship because on router 1 we are going to run ES number 100, on router 2 we are going to run BGP ES number 200. But between router 2 and router 3 we will have iBGP neighborship. Between router 3 and router 4 we will have iBGP neighborship, and between router 4 and router 5 also we will have iBGP neighborship. So let me configure the scenario. R1, R2, R3, R4 and R5. Okay, let's start from router 1. First of all, let me assign IP address. Interface fast Ethernet 0/0, say no set. And here I am going to assign IP 10.1.1.1, let's say 255.255.255.0. On my LAN interface, on fast Ethernet 1/0, IP address is 12.1.1.1, 255.255.255.0, exit. Fine. On router number 2, config T, interface fast Ethernet 0/0, say no set, and IP address 12.1.1.2, 255.255.255.0, exit. Interface fast Ethernet 1/0, no set, and here IP address is going to be 23.1.1.2, 255.255.255.0. Done. On router 3, interface fast Ethernet 0/0, say no set, and IP address is 23.1.1.3, 255.255.255.0, exit. Interface fast Ethernet 1/0, say no set, and IP address 34.1.1.3, 255.255.255.0. We can check connectivity. Do ping 23.1.1.2. I'm able to ping router 2 or not? Yes, I am able to ping router 2 from router 3. Let me configure IP on router 4. Config T, interface fast Ethernet 0/0, say no set, IP address 34.1.1.4, 255.255.255.0, exit. Interface fast Ethernet 1/0, no set, and IP address 45.1.1.4, 255.255.255.0, exit. Do ping 34.1.1.3. Let me check router 4 is able to ping router 3 or not. So yes, router 4 is able to ping router 3. Finally, let me configure IP on R5. Interface fast Ethernet 0/0, IP address 50.1.1.1, 255.255.255.0, exit. Sorry, interface fast Ethernet 0/0, say no set. Interface fast Ethernet 1/0, say no set here also, and IP address 45.1.1.5, 255.255.255.0, exit. Do ping. Let me ping router 4 from router 5. Ping 45.1.1.4. Okay, so I'm able to ping R4 from R5. Now let me configure BGP on all routers. Let's start from router 1. On router 1, I'm going to run this command, router BGP S number 100, and then I'm going to say neighbor. Who is neighbor? 12.1.1.2, IP address of router 2, and remote AS of neighbor is 200. Correct? And then I will advertise one network in BGP here, 10 network. So network 10.1.1.0 mask 255.255.255.0. and now if you will check BGP table, so IP BGP here, so this router have installed this network in their BGP table. This network is valid as well as best, and you can see next hop for this network is 0.0.0. that means this network is self advertised network. Fine. But when router 1 will advertise this prefix to router 2, right, it will not advertise this network with next hop 0.0.0. It will advertise this prefix with next hop 12.1.1.1. Correct. Now I am going to configure BGP on router number 2. So say router BGP AS number 200 here, and then neighbor, who is neighbor 12.1.1.1, whose remote AS is 100. Correct. There is one more neighbor, neighbor 23.1.1.3, IP address of router 3, and remote AS of this neighbor is 200. Fine. So you can see we have BGP neighborship with 12.1.1.1. Neighbor 12.1.1 is up. Fine. We don't have any BGP neighborship between router 2 and router 3 now, because I have not configured BGP on router number 3. Fine. So now I am going to show you BGP table of router 2. So IP BGP. So you can see BGP table of router 2. Inside the BGP table of router 2, this prefix is here 10.1.1.0/24. Next hop is 12.1.1.1. who have advertised, means router 1 have advertised this prefix to router 2, and this network is now only valid, not best. But after some time you will see this network is valid as well as best. So when this prefix will become best, then router 2 will advertise it with other neighbor. So guys, my question over here is, let's say here on router number 3 also I have configured BGP. I have configured BGP on router 3 also, and we have BGP neighborship between router 2 and router 3. So will R2 advertise this prefix to router number 3 or not? See, this prefix is now valid as well as best. So tell me, R2 will advertise this prefix to their other IBGP neighbor or not? To their IBGP neighbor. Yes, because this router have received this prefix from their eBGP neighbor. Correct. So let me configure BGP on router 3 also. Router BGP is number 200. Here I am going to say neighbor 23.1.1.2, remote AS is 200. Soon BGP neighborship will come up between router 2 and router 3 also. You can see the log message. And now so IP BGP. Let me check BGP table of router 3. Now this prefix is available in BGP table of router 3, but this prefix is not best. This prefix is only valid. Why? Tell me the reason. Why this prefix is valid only, not best? Because see, next hop is 12.1.1.1, and is 12.1.1.1 is reachable from router 3, guys? Is this IP address reachable from router 3? Can R3 ping 12.1.1.1? No. No. This is next hop rule in case of IBGP. Whenever router advertise prefixes to their IBGP neighbor, router neighbor modify next hop address. So router 2 have not modified next hop address. Router 2 have advertised this prefix to router number 3 as it is with same next hop IP address. And that is the reason why 10 prefix is not best on router number 3. This prefix is only valid. So if this prefix is only valid in BGP table, router 3 will not install it in their routing table. So IP route BGP, you can see BGP routing table, and router 3 will not advertise it with their any other neighbor. Fine. So let me configure BGP first on router number 4. Say router BGP 200, and I am going to say neighbor 34.1.1.3, remote AS is 200. And on R3, so run section BGP. Let me check BGP configuration here. Neighbor 23.1.1.2. I have defined only this neighbor, so let me define R4 is also your neighbor. Router BGP 200 and neighbor 34.1.1.4, remote AS 200. Now BGP neighborship will come up between router 3 and router 4 also. You can see the log message, but On R4 you can check BGP table. So IP BGP. R4 have not received any prefix from router number 3 from their neighbor. Done. Now I am going to configure BGP on R5. Before that, let me define one more neighbor command here. BGP 200, say neighbor 45.1.1.5 and remote AS is 200. And now let me configure BGP on R5. Router BGP AS number 200, say neighbor 45.1.1.4 remote AS 200. And I am going to advertise one network also here 50.1.1.0 and mask is 255.255.255.0. Fine. Now so IP BGP. Soon this prefix will become best also. After that it will advertise this prefix with router number 4 with their neighbor. So IP BGP summary. Who is neighbor? 45.1.1.4 means router 4. This is IP address of router 4. Right. So IP BGP. Yes, now you can see this prefix is valid as well as best. Next hop is 0.0.0 means self-advertised prefix, and router 5 will advertise this prefix to router 4. So IP BGP. Here we are able to see 50 prefix. And this prefix is valid as well as best because next hop is 45.1.1.5 and this IP address is reachable from router number 4. Now question is, will router 4 advertise this prefix to router 3? Will R4 advertise this prefix to router 3? No, because R4 is learning this prefix from their IBGP neighbor, so it will not advertise it to other IBGP neighbor. Loop avoidance mechanism in IBGP. So because of that you can check BGP table of R3. So IP BGP, you can see we have only this prefix, means router 4 is not advertising 50 prefix to router number 3. Fine. Now on R3 we don't have 50 prefix, but we have 10.1.1.0/24 prefix, but this prefix is only valid, not best, because this next hop is not reachable. Now we have multiple options. I can configure one static route for this next hop IP address. If this next hop IP address will become reachable from R3, this prefix, this network automatically become best. Or as you know, router 2 is border router, because router 2, why we are saying router 2 is border router, because router 2 is connected with both neighbor, with IBGP neighbor and eBGP neighbor. So that type of router is called border router in BGP. And on border router you can run one command. You can tell to border router that whenever you will advertise a prefix to your IBGP neighbor, please modify next hop address. Please modify next hop address. But you cannot run this command on normal router, like on router number 3 or router number 4. We can't run this command. But on border router we can run. So in this scenario, router 2 is my border router, right? Router 2 is my border router. So on router number 2, I can run one command, router BGP 200, router BGP 200, and say neighbor, who is neighbor 23.1.1.3, and I can say next hop self. So with the help of this command, what I am telling to router 2, that whenever you will advertise a prefix to this neighbor, please modify next hop self. Please send your exit interface IP address as a next hop address. Once I will hit enter over here, and then you will check BGP table of R3. So now you can see next hop is still what, 12.1.1.1. So I can run this command here, clear IP BGP star SOP in, and then so IP BGP. Again I will check BGP table, and now you can see BGP table of R3. Now 10.1.1.0/24 network is valid as well as best. Why? Because next hop is reachable. Because now next hop is reachable. So now for R3 this network is valid as well as best. So R3 will install this network in their routing table. Correct, it have installed it in their routing table, and now R3 will advertise it to their other neighbor. Am I right? Will R3 advertise this prefix to R4? No, because R3 is learning this prefix 10 prefix from their IBGP neighbor, so it will not advertise to other IBGP neighbor. And guys, this command, next hop self command, is applicable only on border router. Always keep in mind this. Then what we need to do here? How these two LAN can communicate with each other? How these two LAN can communicate with each other? To understand this, you have to understand route reflector concept in BGP. Route reflector in BGP. See, in route reflector, we have many types of router in BGP. Let me discuss route reflector first, then again I will come on this topology. We have actually three types of router in route reflector. We have three types of router in route reflector, like remember OSPF, types of router in OSPF: ABR router, ESBR router, regular router, internal router, backbone router, right? These type of routers are there in OSPF. So like that, we have some types of router in route reflector. Route reflector. What is route reflector, guys? Route reflector is used to break IBGP loop avoidance mechanism rule. It is used to break IBGP loop avoidance mechanism. It is used to break IBGP loop avoidance mechanism. IBGP loop avoidance mechanism is do not send a prefix to your IBGP neighbor which you have learned from other IBGP neighbor. So in route reflector, we have some types of router. We have three types of router. First one is route reflector server, and by default all BGP routers are route reflector server. If I will talk about this scenario, so in this scenario, R2, R3, R4, R5, all routers are server and their neighbor are non-client. So second type of router is route reflector client. We can say route reflector client. And third type of router is route reflector non-client. Okay, so let's say I have three routers here: R1, R2 and R3. On these all routers we are running, let's say, BGP AS number 100. Here we are running BGP AS number 100. Here we are running BGP AS number 100, and here also we are running BGP AS number 100. So we will have IBGP neighborship between router 1 and router 2. IBGP neighbor. Here also we will have IBGP neighbor SIP between router 2 and router 3. Fine. So in this scenario, let's say router 1 is connected with one network, this network 10.1.1.0/24. Fine. R1, when I will advertise this network in BGP, R1 will advertise this network information to R2. But R2 will not advertise this network information to R3 because of IBGP loop avoidance mechanism rule. Correct? You know why? Because R2 by default, as I told you, all routers are route reflector server. So R2 is route reflector server and their neighbor are non-client. Means R1 is non-client non-client, and R3 is non-client. Okay, like for R3, let's say R3 is server and their neighbor R2 is non-client, and rule is if a server will receive prefix from their non-client, then it will not advertise to other non-client neighbor. Same thing happening here. Router 2 is receiving a prefix from their non-client neighbor, so it will not advertise same prefix to their other non-client neighbor. So here what I can tell to router 2, that your neighbor router 1 is not non-client, your neighbor router 1 is client. Or I can tell to router 2, your neighbor router 3 is not non-client, your neighbor router 3 is client or server. Then router 2 will advertise TAN prefix with router 3 also. So if router 2 means any BGP server router receiving prefixes from a non-client neighbor, then router will advertise to other server neighbor or client neighbor, but it will not advertise to other non-client neighbor. If a server will receive prefix from their non-client neighbor, then server will not advertise to other non-client neighbor. In all other scenario, like what we can say, see here, let's say a server is receiving some prefixes from non-client, then it will not advertise to other non-client, correct? But if a server is receiving prefix from their client neighbor, then definitely it will advertise to their other non-client neighbor. If a server is receiving prefixes from their non-client neighbor, then server will definitely advertise it to other client neighbor. If a server is receiving some prefixes from their client neighbor, then it will advertise that prefix to their other client neighbor. So in only one scenario, you can see in this scenario, a server will not advertise prefixes to their other IBGP neighbor. If a server is receiving prefixes from non-client neighbor, then only server will not advertise that prefix to their other non-client neighbor. And by default, all routers are server and their neighbor are non-client. So let's say I have some router R1, R2, R3, R4, R5, R6. Okay, and here we are running BGP number, let's say 100. So router 1 is server, their neighbor is non-client. Router 2 is server and their neighbor are non-client. Both neighbor are non-client. For R3 is server and their both neighbor are non-client. For R4 is server and their both neighbor are non-client. R5 is server and their both neighbor are non-client. R6 is server and R5 is non-client neighbor by default. Getting my point? So in my scenario, guys, actually what is happening here, R1 have advertised this network information to router 2 with what next hop? 12.1.1.1. R2 have advertised that prefix to router number 3 with same next hop IP address, but on R2 we have run next hop self command. So R2 started advertising this prefix, TAN prefix, with their on exit interface IP address as a next hop. But when router 3 received this network, TAN network, it is receiving from non-client neighbor, so it is not advertising to their other non-client neighbor, means to router number 4, and that is the reason why we are not able to see TAN prefixes in the BGP table of R4. In BGP table of R4, we are not able to see TAN network, because R3 is receiving TAN prefixes from router 2 and router 2 is their non-client neighbor, and router 4 is their other non-client router. So it will not advertise receive prefix from non-client to other non-client. So what we can do on router number 3, I am going to tell to router 3, your neighbor router 4 is client. Now router 3 is receiving one prefix from non-client neighbor, so it will advertise to their client neighbor. It will advertise to their client neighbor. So simply I can run one command on R3. Command is this one, router BGP 200 and say neighbor 34.1.1.4 and route reflector client. Once I will run this command here, now you can see BGP neighborship is resynchronized, and now if you will check BGP table of R4, you can see router 4 have received this network 10.1.1.0/24, but still this network is only valid, not best, because of next hop. Next hop is 23.1.1.2 and 23.1.1.2 is not reachable from router number 4. That is the reason this prefix is not best. This prefix is only valid. So if this prefix is only valid, not best, that means router 4 will not install it in their routing table BGP, you can see, and router 4 will not advertise it to their any other neighbor. So what we can do here? So IP BGP. See, here you can configure one route for this network. You can configure a static route, or you can advertise this network in BGP, or you can configure route reflector also here. So that this network should be reachable from router number 4. This IP address should be reachable from router number 4. Okay. So first option here is configure a static route for 23 network. On R4, I am going to configure one static route. IP route 23.1.1.0. Let's say for this network, I am going to configure one static route on R4. Or I can configure a static route for exact this IP address. Subnet mask is 255.255.255.255, and we can say exit interface is fast ethernet 0/0, and next hop IP address is 34.1.1.3. Now 23.1.1.1 is 23.1.1.2 is reachable from R4. 23.1.1.2. 23.1.1.2. We are not able to ping 23.1.1.2 because router 2 don't have route for 34.1.1. In the packet source IP will be 34.1.1.4. But check BGP table. So IP BGP. See, this prefix is now valid as well as best, because this IP address is now route is available for this IP address. Actually, route is available for this IP address. So IP route, you can see static route for 23 network. Because of that, so IP BGP, this prefix is valid as well as best. Now question is, will R4 advertise this prefix to R5 or not? Will R4 advertise this prefix to R5 or not? No, because R4 is server, R3 is non-client, R5 is non-client. Both neighbor are non-client. And here second option is what? If I will remove a static route, say no to this. If I will remove this static route, and now if you will check BGP table again, so IP BGP, soon this prefix will be valid only, not best. You can see now this prefix is only valid. What is second option? Second option is we can advertise this network 23.1.1.2 in BGP. Go to R3 and advertise this network in BGP. Router BGP 200, and here we can run this command, network 23.1.1.2 0 mask 255.255.255.0. Now R4 will receive this network through BGP. So IP BGP. You can see router 4 have learned this network through BGP. And next hop is 34.1.1.3, which is reachable from router 4. Correct? And because of that, this network is also valid as well as best. This is second option. Now what is third option? Third option is route map. See, here I am going to remove this command also from R3. Say no to this command, because generally we will not advertise when link into BGP. So I have removed this command. Third option is route map. We can create one route map on router 4. Whenever we can actually tell to router 4, whenever you will receive a prefix from R3, please put next hop IP address 34.1.1.3. I can tell to R4, whenever you will receive a prefix from router number 3, please put next hop address 34.1.1.3, which is IP address of router 3. Getting my point? Or you can configure route map on router 3 and you can tell whenever you will advertise a prefix to router number 4, please put next hop address 34.1.1.3. Either I can create route map on router 3 or I can create route map on router 4. So let me configure route map on router 4, guys. On router 4, if I will create one route map, let's say name is next hop permit. Right here I am going to say set IP next hop 34.1.1.3, 34.1.1.3, and now I will call this route map in BGP. Router BGP S number 200, say neighbor, who is neighbor 34.1.1.3. From this neighbor, for this neighbor, use route map next hop, name of route map next hop, and then in which direction you want to apply. So I want to apply it in direction, that whenever you will receive prefix from 34.1.1.3. Fine. And now you can check BGP table. So IP BGP. Wait for some time. You can see next hop IP address is still 23.1.1.2. So I will clear IP BGP star soft in. And now so IP BGP, you can see BGP table. Now next hop IP address is 34.1.1.3, which is reachable from router number 4. Because of that, this network is valid as well as best. And if this network is valid as well as best, it will install it in their routing table. So IP route BGP. But R4 will not advertise this prefix to R5 because it is receiving from their non-client neighbor. So it will not advertise to other non-client neighbor. So again here we need to configure what? Route reflector. Either I can tell to router 4 your neighbor router 3 is client or router 5 is client. Correct? When I am running this command clear IP BGP star opt-in, actually router is sending route reflector message, route refresh message, last message of BGP. So here see R4 is not advertising, so IP BGP 10 prefix to router number 5. So IP BGP, here you can see BGP table. Again we need to configure route reflector. So let me take you to R4, and on R4 I am going to configure router BGP 200 and say neighbor 45.1.1.5. let's say router 5 is route reflector client, Now router 4 will advertise the 10 prefix to router number 5. Now you can check R5 BGP table. So IP BGP, and you can see again this prefix is only valid node based, because this next hop IP address is not reachable from R5. So here again I can create one route map on router 4 or on router 5. If I will configure route map on router 4, I will apply it in odd direction. When I will if I will configure route map on router 5, I will apply it in direction. So tell me on which router you want to apply route map. On R4. So on R4 we can configure one route map, and this is the actual way to modify next hop IP address in BGP by creating route map, right? You should not configure a static route for next hop IP address. You should not advertise WAN link in BGP. You should create route map every time. Route map, let's say name is PM, because on router number 4 we have already one route map with name next hop. So here I'm going to say name PM, and then say permit with permit statement, and set IP next hop 45.1.1.4. I'm going to call this route map in BGP router BGP 200, and say neighbor 45.1.1.5 route map PM direction out. Now whenever router 4 will advertise any prefix to this neighbor, it will call route map PM in odd direction, and in route map PM we have set next hop IP address 45.1.1.4. That means for all prefixes next hop will be 45.1.1.4, right? So on R5 now you can check BGP table. You can see 10 prefix is still valid not based because of next hop. Let me clear IP BGP star soft in, and now show IP BGP. You can see 10 network is now valid as well as best. So R5 will install it in their routing table. Fine. Any doubt till here? Hmm. So is means here we have very less very small topology. If topology is large, let's say there are lots of routers, right? So all routers will install all networks between router in their BGP table, also in their routing table, also unnecessary. Like here if I will advertise, if I will check BGP table, so IP BGP, see how many prefixes are there, only 2. But if I will advertise all WAN link in BGP, then inside the BGP table of all routers 45 network will be there, 34 network will be there, 23 network will be there, correct? But router 5 never need to forward any packet to 34 network or 23 network. Unnecessary router 5 will install those networks in their BGP table and their routing table. So that's why we are not actually not advertising WAN link in BGP. Yes. Yes, for IBGP. As I told you, route reflector is for breaking the rule of IBGP. Loop avoidance mechanism of IBGP. Okay. Now for 50 network, see here on R5 we are advertising 50 network in BGP. Same next hop is 0.0.0. R5 will advertise 50 network to R4. So IP BGP. Yes, R5 have advertised it to R4 with next hop 45.1.1.5, but R4 will not advertise 50 network to R3. Yes or no? So IP BGP. R4 is advertising 50 networks. Now you tell me why. How? How R4 is advertising? Very good. R5 is client of R4. Because of that, R4 is advertising 50 network to R3. But next hop IP address is not reachable from R3. Because of that, this prefix is only valid, not best. So here what we need to do? We need to create one route map to modify next hop address. Yes or no? So on R3, route map, or name of route map is PM, let's say permit, and set IP next hop 34.1.1.4 should be the next hop IP address. Whenever R4 will advertise any prefix to router number 3, next hop should be what? 34.1.1.4. Okay, now I will call this route map in BGP. Router BGP 200 and then neighbor 34.1.1.4. Use route map name PM in which direction? In indirection, correct? And clear IP BGP star soft in, and so IP BGP. Now you can see 50 prefix is valid as well as best because next hop address is reachable. Now will R3 advertise 50 prefix to R2? Will R3 advertise 50 prefix to R2? R no?
Yes, like it's a border router.
So run section BGP. See the BGP configuration. Here we have configured this neighbor, means router 4 is route reflector client, because it is receiving from client, so it will advertise to other non-client. So because of that, on router number 2 we can see so IP BGP, right? 50. But this prefix is again not best because of next hop. So again here we can configure what? Route map, or I can configure route map on router number 3. Let's say on router number 3, let me create one more route map. And this time name is, let's say, NB, anything. Next hop and say permit, set IP next hop 23.1.1.3. Next hop should be 23.1.1.3. I will call this route map with BGP, router BGP 200, and say neighbor 23.1.1.3. use route map next hop direction. Which direction? Out. 1. Yes, sorry. 2. Direction out. Right, and then clear IP BGP star soft in. So IP BGP fine on router number 2. So IP BGP, wait, clear IP BGP star soft in. So IP BGP, you can see 50 prefix is now valid as well as best. Now R2 will advertise 50 prefix to router number 1 because router 1 is their eBGP neighbor, and whenever router 2 will advertise it to their eBGP neighbor, it will modify next hop IP address. So on R1 we can check, so IP BGP, you can see next hop IP address is what? 12.1.1.2. and now these two LAN user can communicate with each other. Ping 50.1.1.1, source is 10.1.1.1. See, ping is working. So this is actually a rule of IBGP, rule of eBGP, loop avoidance mechanism, route reflector, and next hop self. Next hop self rule. Next hop will be always modify in case of eBGP neighbor. Next hop will be not modify in case of IBGP neighbor. To break IBGP loop avoidance mechanism rule, we have route reflector feature. There are three types of router in route reflector client, route reflector server, and route reflector non-client. By default, all routers are route reflector server and their neighbor are non-client. Done guys till here? How to check show IP BGP? Sorry, show IP BGP summary. To check neighbor table, show IP BGP summary, you will run this command. Here we are not able to see this neighbor is iBGP neighbor or eBGP neighbor. This neighbor is iBGP neighbor or eBGP neighbor. Are you able to see? Where? Remote AS 200 and my local AS number is 100. Okay, but you can run this command also, show IP BGP neighbor. It will show you. Let me maximize it and let me run this command again. Neighbor is external. On router number 2, if you will run this command, show IP BGP neighbor, you can see 12.1.1.1 is external link and one more neighbor is there, 23.1.1. Another neighbor is 23.1.1.3 internal link. Okay, like this also we can check. Fine. After that, in BGP we need to learn indirect neighborship. These are direct neighborship, right? Direct neighborship between router. Now let's understand indirect neighborship in BGP. Let's say guys, here I have a topology like this. As I told you in previous yesterday class, that we can form BGP neighborship with indirectly connected router also. Let's say I have one router here R1 and one router here R2. Between R1 and R2 we have two paths. Let's say R3 and R4 is there like this. Okay, here we have one LAN 10.1.1.0/24. Here I have one LAN to 20.1.1.0/24. Between 10 network and 20 network we have two paths. Correct guys? We have two paths available. So if I want to configure BGP neighborship between router 1 and router 2, if I want to configure BGP neighborship between router 1 and router 2, I can configure BGP neighborship between router 1 and router 3. I can configure BGP neighborship between router 2 and router 3. Or I can configure direct BGP neighborship between router 1 and router 2. How? Let's say here IP address is what? 12.1. Here IP address is 32. Let's say 2. 32.2. So when I will configure BGP on router number 1, I will run command router BGP AS number 100 and then I will define neighbor command. Neighbor IP address is 32.1.1.2 and remote AS is let's say 100 or 200. Correct? In the same way on router number 2 also I will run this command router BGP 100 and the neighbor 12.1.1.1 remote AS is 100. So if 12.1 and 23.1 are reachable with each other, then BGP neighborship will come up. But what will happen if R3 will goes down? BGP neighborship will goes down. Still one path is available, but BGP neighborship is down. So you know how you should configure BGP over here. If you want to form BGP neighborship between router 1 and router 2, then you should configure BGP neighborship with loopback IP address. Here you should create one loopback 1.1.1.1 and here one loopback 2.2.2.2. For reachability between 1.1.1 and 2.2.2, you can run any IGP protocol. Like for reachability between 12.1 and 32.2, you will configure one IGP protocol. Like that, to make reachability between 1.1.1 and 2.2.2, you can configure OSPF protocol here, any IGP protocol. Right? Through IGP protocol 1.1.1 and 2.2.2 are reachable with each other. And now you can configure BGP neighborship between 1.1.1 and 2.2.2. What is benefit? Benefit is if R3 will goes down, then 1.1.1 and 2.2.2 are still reachable via R4. Are still reachable via R4. That means my BGP neighborship is still up. So if you will configure here BGP neighborship by using physical interface IP addresses, then you have problem. Getting my point? But if you will configure BGP neighborship with loopback IP address, right, you have benefit. So whenever we are configuring indirect BGP neighborship, we should configure BGP with loopback IP address, not with IP address of physical interface. Getting my point? So try to understand how we can form BGP neighborship between two router R1, R2. Let's say here we have one loopback 1.1.1.1. Here I have one loopback 2.2.2.2. Now 1.1.1 and 2.2.2 are not connected with each other. Yes or no? So how we can form BGP neighborship between 1.1.1 and 2.2.2? How we can form BGP neighborship between 1.1.1 and 2.2.2? My first requirement is 1.1.1 and 2.2.2 should be reachable with each other. This is first requirement. For that we will configure one IGP protocol. You can configure a static route also, but you can't configure default route. If someone is thinking that I will define one default route on router 1 towards router 2 and I will define one default route on router 2 towards router 1, so BGP will not consider default route. Either you can configure one static route. Here on router number 1 you can configure one static route for 2.2.2, and on router number 2 you can configure one static route for 1.1.1, or you can configure IGP protocol. To form BGP neighborship between 1.1.1 and 2.2.2, first requirement is both should be reachable with each other. We cannot configure default route. BGP does not consider default route for indirect neighborship. So let me do one thing. Let me perform one lab. Again a small lab here of indirect BGP neighborship. R1, R2. Between router 1 and router 2, we are going to use same 12 network 12.1.1.0/24. On R1, we have one loopback 1.1.1. On R2, I have one loopback 2.2.2. One second, guys. हाँ कहू ना हैया खाइ छियै क्लास लऽ कऽ तहन की छै आब हाँ हाँ चलै छै ठीक छै खत्म भऽ गेल ओके ठीक है देख लूँगा ओके सो R1 indirect neighborship in BGP.
So recording is not paused, no?
No. Recording is on. Interface loopback 1. IP address is 1.1.1 255.255.255.255. Exit interface fast ethernet 0/0. IP address is 12.1.1.1 255.255.255.0. Say no set. Done. On router 2, config T, interface loopback 1, IP address is 2.2.2.2 255.255.255.255 and exit interface fast ethernet 0/0 no set, and IP address is 12.1.1.2 255.255.255.0. Fine. Now I am going to configure BGP on router 1. Router BGP, let's say 100. On both router we are running BGP AS number 100. Let's say try to understand indirect BGP neighborship in IBGP first, then we will discuss indirect neighborship in eBGP also. Let's say here AS number is 100 and on router number 2 also AS number is 100. So router BGP AS number 100, say neighbor. This time I am not going to tell to router 1 your neighbor is 12.1.1.2. I'm going to tell to router 1 your neighbor is 2.2.2.2 and remote AS is 100. Correct? Now what will happen? Router 1 will generate one SYN message first. Yes or no? Router 1 will generate one SYN message for this neighbor. But route is not available. Route is not available on router 1. So router 1 will drop SYN message. Getting my point, guys? What will happen after running this command? R1 will generate one SYN message. SYN message. Inside the SYN message, TCP SYN message, source port will be there, destination port will be there, source IP will be there. Source IP will be definitely 12.1.1.1 and destination IP will be 2.2.2.2. Right? So this router need a route for 2.2.2 but route is not available for 2.2.2. So R1 will send SYN message with source 12.1, destination 2.2.2. Okay, and route is not available, because of that router 1 will discard this SYN message. Correct? And on router number 1 you can run this command. So IP BGP neighbor here. Important information is outgoing TTL. What will be the TTL value inside the message? RIB does have a route to 2.2.2. Address tagging is enabled. Just wait. What should be the TTL value? State is idle. We will discuss state also. Here I am looking for outgoing TTL value. Okay, leave it for now. I will show you this also. TTL, TTL, TTL. Are you guys able to see TTL value somewhere? TTL time to live. For IBGP TTL value will be 255. For eBGP TTL value will be 1. Okay, leave. So here this router 1 is going to send SYN message with what next, with what source IP address 12.1.1.1. So if okay, there is one route available for 2.2.2 on router number 1, that means router 1 can send SYN message to 2.2.2, but still source IP is what, guys? 12.1.1.1, but source IP should be 1.1.1. You know why? Because if source IP is 12.1.1.1 and on router number 2 you are going to define neighbor IP address is 1.1.1, so router 2 should receive SYN message from which neighbor? From 1.1.1. it should receive SYN message with 1.1.1. See, on router number 2 also, let me configure BGP. Router BGP, is number 100 and say neighbor 1.1.1, remote AS is 100. Correct? BGP neighborship will not come up here. Am I right? And if you will capture the link, you can see both routers are sending SYN message. Okay, for now route is not available. Let me do one thing. I'm going to configure one static route on router number 2. IP route 2.2.2.2, IP route 2.2.2, and source sorry, mask 255.255.255.255, exit interface fast ethernet 0/0, next hop IP address 12.1.1.2. See the SYN message. Source IP address is 12.1.1.1. So router 2 is sending SYN plus ACK message to 12.1.1.2. But on router number 2, neighbor is 1.1.1, not 12.1.1.1. So in case of in case of indirect neighborship, you need to run one more command on both router. Like on router number 1, I have to tell to router 1, whenever you will send any message to 2.2.2 neighbor, please update source IP address. Please update source IP address. Router BGP is number 100, say neighbor 2.2.2.2 and update source loopback 1. Source IP should be the IP address of loopback 1. And now in this next SYN message, just wait. In next SYN message, you will see source IP address is going to be 1.1.1. See, in this SYN message, source IP 1.1.1, destination IP 2.2.2. So now R2 is replying to 1.1.1. In the same way on router number 2 also, we need to run this command neighbor 1.1.1 update source loopback 1. And on router number 2 also, I am going to define one route, IP route 1.1.1 255.255.255.255, exit interface fast ethernet 0/0 12.1.1.1. Now BGP neighborship will come up. Now you can see BGP neighborship is up. Now we have BGP neighborship between 1.1.1 and 2.2.2. So whenever you need to configure BGP neighborship, indirect BGP neighborship, you should configure BGP neighborship with loopback IP address. So IP BGP summary, who is neighbor 1.1.1. Okay guys, is it clear? Indirect BGP neighborship in case of IBGP, you need to run one more command. First, you should means both IP address should be reachable with each other. For that, you can configure a static route or you can configure any dynamic routing IGP protocol. And secondly, you need to configure update source IP address. Update source IP address. Is it clear?
So this is directly connected only, right?
Not directly connected. 1.1 and 2.2
Oh,
both are indirectly connected, na?
okay, okay, okay.
Correct. Now indirectly connected BGP neighborship in case of eBGP. In case of eBGP, let's say here AS number is not 100, here AS number is 200. And guys, here let's say AS number is 100 and I am going to remove a static route from both router. No IP route 1.1.1 255.255.255.255 fast Ethernet 0/0 12.1.1.1. And on router number 2 also say no IP route 2.2.2.2 255.255.255.255 fast Ethernet 0/0 and 12.1.1.2. I have removed static route configuration. What we can do, we can configure any IGP protocol also like OSPF or EIGRP. So IP BGP summary. BGP neighborship is still up. How? Why BGP neighborship is still up? Guys, remember open message is used to discover BGP neighborship. Once BGP neighborship will establish, routers are not going to exchange any SYN message or open message. Routers are exchanging only keep alive message. See timer. Timer is increasing, and here you can see routers are exchanging keep alive message or not. No. Why routers are not exchanging keep alive message? Because now route is not available. Means after some time BGP neighborship is going to down. Or what we can say, we can shut down interface fast Ethernet 0/0. Shut down and say no, shut down. So IP BGP neighbor. Again you can see a state. Here we can check a state. Hold on time is 180 second. After 180 second it will break the neighborship. Let me create one loopback here, loopback 10 and IP address is 10.1.1.1 255.255.255.0 exit router BGP is number 100 and let's say network 10.1.1.0 mask is 255.255.255.0. So IP BGP and on R2 so IP BGP table of R2 is so IP BGP neighbor. Now state is idle. On R1 also we can check state is idle. We will see BGP states also in upcoming day. Don't worry, there are some states like idle, connect, open. Why BGP now BGP state is idle? Because 1.1.1 and 2.2.2 are not reachable with each other. So here I can configure one dynamic routing router OSPF, let's say process 1 and network 12.1.1.0 while karma 0.0.255 area 0 and then network 1.1.1 0.0.0 area 0. On router number 2 router BGP router OSPF process 1 network 12.1.1.0 wildcard mask this 255 area 0 and network 2.2.2.2 0.0.0 area 0. Wait for OSPF neighborship. So IP OSPF neighborship is in two-way state. So IP route 1.1.1 is not available. OSPF by default OSPF network type is broadcast. Because of that neighborship is taking some time. means it is in two-way state. Here network type should be what, guys? Between two routers, OSPF network type should be what? And now you can see log message BGP neighborship is again up. Why? Because 1.1.1 is now reachable from 2.2.2 through OSPF. Question is, what should be the network type of OSPF between router 1 and router 2? Hmm? By default network type is broadcast here, but what should be the network type? Network type should be point to point. Network type should be point to point. And one more thing I would like to tell you here is, in case of eBGP, directly connected rule is enabled, and in case of IBGP, directly connected rule is disabled. Directly connected rule is disabled, and in case of eBGP, directly connected rule is enabled. Means in IBGP you can configure BGP neighborship with indirectly, sorry, we can form indirectly connected IBGP neighborship, but we cannot configure indirectly connected eBGP neighborship by default, because directly connected rule is enabled there. Means router will check neighbor is directly connected or not. In case of IBGP, router will not check, because this rule is by default disable in case of IBGP, but directly connected rule is enabled by default in case of eBGP. How to check that? We can run this command, I think so. So IPBGP neighbor. Yes, outgoing TTL here is, you can see outgoing TTL is 255. I was looking for this point. Where is information about the directly connected rule? Okay, I will check it. I will check it in case of eBGP. I think it's not showing in case of IBGP. Let me do one thing. Here on router number 2, I am going to change AS number. Here I am going to configure now AS number 200. I am going to configure AS number 200 and see what are the difference. So on router number 2, I am going to remove BGP configuration. No router BGP 100. Done. Again I am going to configure router on router number 1 also. Let me remove BGP configuration. No router BGP as number 100, and 1.1.1 and 2.2.2 are reachable with each other. Ping 2.2.2 source 1.1. 1. Both are reachable with each other through OSPF. So IP route OSPF through OSPF. This router have learned 2.2.2 network. Okay. So we can configure indirect BGP neighborship. Router BGP AS number 100. Say neighbor is 2.2.2. Remote AS. This time remote AS is 200. Remote AS is 200. And neighbor 2.2.2. Update source loopback 1. Okay, now on router number 2, router BGP is number 200. Okay, neighbor 1.1.1, remote AS 100, and neighbor 1.1.1, update source. You will run this command always in case of indirectly connected neighborship. Update source loopback 1. But you can see BGP neighborship will not come up. BGP neighborship will not come up because as I told you, in case of eBGP, directly connected rule is enable. By default, directly connected rule is enable, and here outgoing TTL value is also TTL value will be 1 in case of eBGP neighborship. In case of eBGP neighborship, TTL value will be 1. In case of iBGP neighborship, TTL value in all messages will be 255. So here if you will run this command, so IP BGP neighbor, you can see outgoing TTL value. Outgoing TTL value is, where is the information about outgoing TTL value? See, external BGP neighbor not directly connected. External BGP neighbor not directly connected. It's saying external BGP neighbor not directly connected. So neighbor should be directly connected in case of eBGP. Neighbor can be directly connected or can be indirectly connected in case of iBGP. So here actually you need to run one command on router number 1. On router number 1, we can disable this rule by running this command neighbor 2.2.2, or we can say disable connected check. After running this command, router will not check directly connected rule, and now BGP neighborship will come up. Let me do same thing on router number 2 also. Router BGP 200, say neighbor 1.1.1, disable connected check. Yeah, now you can see BGP neighborship is up between router 1 and router 2. This is how we can configure indirectly connected neighborship in case of eBGP. In case of EGP, you have to disable directly connected rule also. And so IP BGP neighbor outgoing TTL value is 1 in case of eBGP. So here we don't have any problem, because if TTL value is 1, then also router 1 can forward messages to router 2. But let's say router 2 is connected with another router. My scenario is like not like this. My scenario is, now let me design one another scenario here. Let me delete this scenario. Let's say my scenario is like this: R1, R2 and R3. This time I want to form BGP neighborship between router 1 and router 3. Indirectly connected neighborship. eBGP indirectly connected neighborship. Let's say on router 1 we have one loopback, again 1.1.1, and on router 3 I have one loopback 3.3.3. I want to form BGP neighborship between 1.1.1 and 3.3.3. First requirement, 1.1.1 and 3.3.3 should be reachable with each other. Then we need to disable directly connected check rule. After that, we need to increase TTL value also here. Because if router 1 will forward any message to 3.3.3 with TTL value 1, right, router 2 will discard that message because TTL value on router number 2 will become 0. Yes or no? So see how you will configure this scenario then. Let's start from R1 again. Interface loopback 1, IP address 1.1.1.255.255.255.255, exit interface fast ethernet 0/0, say no shut, and IP address is 12.1.1.255.255.255.0, exit router rip. I can configure any IGP protocol, version 2, no auto, summary, and network 1.1.1 and network 12.1.1.0. Then go to router 2, interface fast ethernet 0/0, IP address is 12.1.1.2.255.255.255.0, say no shut, exit interface fast ethernet 1/0, no shut, and IP address 23.1.1.2.255. Router rip version 2, no auto summary, and network 12.1.1.0 and network 23.1.1.0. So IP route rip. Soon router 2 will learn 1.1.1. What happened? Fine. Router 2 have learned 1.1.1. Let me configure R3. Interface loopback 1, IP address 3.3.3, 255.255.255.255, exit interface fast ethernet 0/0, say no shut, and IP address 23.1.1.3, 255.255.255.0, exit a router rip version 2, no auto summary, network 23.1.1.0 and network 3.3.3.3. So IP route rip. It have learned 1.1.1, and now let me check connectivity between 1.1.1 and 3.3.3. So yes, there is connectivity. That means we can form BGP neighborship between 1.1.1 and 3.3.3. How we will configure BGP on router number 1? I am going to run this command, router BGP S number 100. Let's say on router number 1 I am running BGP S number 100, and on router number 2, router number 3, we are running BGP S number 200. Or let's say here AS number is 100. That means we are configuring IBGP neighborship. Indirectly connected IBGP neighborship. If here AS number is 200, that means we are configuring indirectly connected eBGP neighborship. So first let me configure IBGP neighborship here. In case of IBGP neighborship, you will run this command neighbor 3.3.3.3 remote AS 100. Then neighbor 3.3.3.3 update source loopback 1, and then finally on router number 3 router BGP AS number 100 neighbor 1.1.1 remote AS 100 and neighbor 1.1.1 update source loopback 1. So you can see BGP neighborship is up. Very easy. Now how we will configure eBGP indirectly connected neighborship here. No router BGP AS number 100, and on router number 1 also say no router BGP AS number 100. Okay, now I am going to configure here 200. So on R1 we will run router BGP AS number 100 and neighbor 3.3.3.3 remote AS 200 or 300, let's say 300. AS number here is 300. So AS number 300. After that neighbor 3.3.3.3 update source loopback 1 on R3 router BGP AS number 300 and neighbor 1.1.1 remote AS 100 and neighbor 1.1.1 update source loopback 1. Now BGP neighborship will not come up. Why? We have two problem here. One is directly connected check rule is enabled in case of eBGP. Second problem is TTL value is 1 in BGP message. TTL value is going to be 1 in case of eBGP. So to resolve these two problems, what we can do? Simply on R1 we can run one command neighbor 3.3.3.3 eBGP multi-hop. Multi-hop means TTL value. What TTL value is required here? 2. If TTL value is 2, then R1 can send any message to 3.3.3. With TTL value 2, R1 can send any message to 3.3.3. So here we need to configure what eBGP multi-hop 2 means TTL value 2. Once I will run this command, automatically directly connected rule will disabled. Automatically directly connected rule will disabled here. So let me hit enter, and on R3 also neighbor 1.1.1 eBGP multi-hop 2, and now you will see BGP neighborship will come up.
Praful, I have one doubt. Okay.
Yeah.
See, if you have a hub and spoke locations setup like that,
Okay.
if we don't know the destination, we don't know how many routers should be put in.
So you should configure eBGP multi-hop 255. Once you will increase TTL value, router will automatically disable directly connected check rule. So this is how we configure indirectly connected IBGP neighborship and indirectly connected eBGP neighborship. Any question guys still here?
What is the eBGP multi-hop maximum value? It is 255 or we can give more than that?
Okay.
250.
Yes. So hope now you can form BGP neighborship with directly connected router, with indirectly connected router. You can form IBGP neighborship with directly connected and indirectly connected router. You can form eBGP neighborship with directly connected and indirectly connected router. You can enable or disable directly connected check rule for eBGP neighbor, right? You can change TTL value for eBGP for indirectly connected eBGP neighbor, because for directly connected you don't need to change TTL value, because TTL value should be 1 for directly connected neighbor, but for indirectly connected neighbor TTL value should be more than 1. And now let's say I have some prefixes on router number 1. On router 1 I am going to create some loopback. 10.1.1.0/24, 10.1.2.0/24, and 10.1.3.0/24. Let me create this loopback on router 1. Interface loopback, let's say 10. IP address 10.1.1.1 255.255.255.0. Interface loopback 11. IP address is 10.1.2.1. Interface loopback 12. IP address is 10.1.3.1. Right? I'm going to advertise this network in BGP, router BGP 100, and say network 10.1.1.0 mask 255.255.255.0, network 10.1.2.0, network 10.1.3.0. Correct? So IP BGP, right? It have installed this all network in BGP table. So R1 will share this network information to their neighbor. So IP BGP summary to 3.3.3. So let me show you BGP table of R3. So IP BGP. Soon it will receive others network also. Okay, so IP route BGP. So you can see it have learned these all prefixes. But if you will check routing table of router 2, so IP route, router 2 don't have any network. Correct, guys? So let's say on router number 3 also I have some network like 30.1.1.0/24, 30.1.2.0/24, and 30.1.3.0/24. On R3 also, let me create this loopback. Interface loopback 1, IP address 30.1.1.1, 255.255.255.0. Interface, sorry, loopback 1 IP address would be 3.3.3. 12. Done. Let me advertise this network in BGP. Router BGP 300 and say network 30.1.1.0 mask 255.255.255.0, network 30.1.2.0 and 30.1.3.0. So IP BGP. See BGP table of router 3, and so IP BGP. BGP table of router 1. Soon router will receive other network also. But can 10 network communicate with 30 network? Tell me, guys. Can I ping 30.1 from 10.1? I can't ping. Why? Because router 2 don't have any route. So IP route BGP. Here we have these all 30 prefixes. On router number 3 also, so IP route BGP. We have these all prefixes here also, right? But on router number 2, so IP route, we don't have 10 or 30 prefix. Correct? Because of that, I can't ping 30.1.1.1. Source is 10.1.1.1. Ping will not work. So in this scenario, we will configure MPLS here. We will configure MPLS here. So my scenario is not this. My scenario is like this. Let's say there is one service provider, R1, R2, R3. This is service provider R1, R2 and R3. Let's say we have two customer, means one customer side 1 is here and another side of same customer is here connected with R3. One side of a company is connected with R1 and one side of a company is connected with R3. Here also I have one router in side 1, I have one router in side 2, let's say, right? So what I will do, this is let's say R4, this is R5, R5, and here I have one LAN. Here also I have one LAN. This is service provider. Service provider. Okay, so guys, in this scenario, let's say here we are running this network 10.1.1.0/24. Here we are running one network that is, let's say 50.1.1.0/24. Fine. So which type of router it is? This is CE router, customer edge router. This is also customer edge router, CE router. This is PE router, provider edge router. This is another PE router. This is another PE router. And which type of router R2 is? This is P router.
Sorry for the interruption.
Hmm.
So in that last scenario, okay,
Okay.
R1, R2, R3, if we configure that RIP protocol in R2 also, then we can able to ping, right?
But no, brother. Oh yes, but we have not advertised 10 and 30 prefixes in RIP. We have not advertised 10 prefixes or 30 prefixes in RIP. So router 2 is not getting those prefixes. Here, I don't want to install this network and this network in the routing table of R2 because R2 is my normal router, P router, provider router. I want to exchange these two prefixes between PE to PE. So we will form BGP neighborship between router 1 and router 2. Inside the service provider, we are running, let's say, OSPF. So I will not advertise this network in OSPF. Right? Because like this customer, there are many more customers. Here also there is another company, right? Like this. So I don't want to inject customer network in provider routers. So what will happen in this scenario? Customer edge router will share prefixes to P router. P router will share prefixes to other P router, and other P router will share that prefixes to another side. Right? And how these two customers will communicate with each other? Through MPLS. In service provider network, we will run MPLS. This is actual implementation of BGP. Let's say service provider is using AS number 100. Here we are running AS number 200. Here also we are running AS number 200. So which type of neighborship will form between P to C? eBGP or iBGP? eBGP. Which type of neighborship will form between router 1 and router 3? iBGP. And here we will have eBGP neighborship. Correct? Correct? So now you tell me, when R4 will advertise this network to R1, what will be the next hop IP address? IP address of this interface? Correct, guys? And will R4 include their AS number in the update? Yes, because it is forwarding update message to their eBGP neighbor. So it will include their on AS number 200 in the update. When R1 will advertise update, same update message to R3, it will not include their AS number. So R3 will receive update message with AS number 200. And when R3 will advertise the update to R5, R5 will see their own AS number in the update. So R5 will discard update. Yes or no? R5 will discard the update message. This is loop avoidance mechanism of eBGP. Whenever you will find your own AS number in the update, you will discard the update message. So here in this scenario, we need to configure many more features. So tomorrow we will see the configuration of this topology. And this is, guys, actual implementation of BGP in real time. This is actual implementation of BGP in real time. To make you understand this scenario only, I have discussed directly connected rule, indirectly connected BGP neighborship, indirectly connected iBGP neighborship, eBGP neighborship, whatever things we have discussed till now, just to make you understand this topology, configuration of this topology. Okay, so whatever practical today we did, you should configure all the things by yourself, and tomorrow we will see this lab configuration. In this lab, in service provider network, again you will create one loopback here, 1.1.1, and here 3.3.3, and you will form BGP neighborship between 1.1.1 and 3.3.3. You will not use physical interface IP address. Why? Because between router 1 and router 3, you in the real time you will have many other paths as well, and all paths are reachable through IGP protocol, right? So if you will use this interface IP address and this interface IP address to form BGP neighborship, if R2 will goes down, your BGP neighborship will goes down. But if you will configure BGP neighborship with loopback IP addresses, right, even one path will goes down, you will have alternate path. IGP protocol will automatically detect another path. Okay, is it clear? So tomorrow we will see, guys, this topology. That's all for today. Now if anyone have any question, please ask.